Okay, we are going to take a look at the domain and range introduction Desmos activity. So first thing we're going to do is explore domain. So a mathematician says something is wrong with the shading of this graph. Something is wrong with my mouse. Something is wrong with the shading of this graph. What do you think it is? So I think that either this line should continue all the way out to the end of the shading, or the shading should stop where the line stops. Let's say that. I think the shading should stop where the line stops. Share with the class and move on. Fix it. So mathematicians, we use this type of shading to represent the domain of a function. To exactly measure the domain of a function, we include all of the x values that the graph crosses. So the domain is all possible x values. So drag the orange point to fix the shading for this graph. So I'm going to drag it over here so that it lines up with my line. I want it to be at 4. Exactly 4. There. Continue. Great job. We fixed the inequality. It's hard to get the domain exactly right by moving the points. That's what I was kind of struggling with. We mathematicians use inequalities to describe domain because they are more precise. So it's more precise to write it out than it is to like draw it out on a graph. So this is the inequality for the graph that one of my classmates created on screen 2. So I'm going to help them by fixing the inequality to correctly represent the domain of the function. So I don't know what is going to show up on your end, but this is the correct inequality. On the left-hand part, I have that filled in dot. That means I'm going to include 1. I'm going to include 1. That 1 is a possibility for the value of x. And that inequality, that graph is going to go all the way to 4, but you'll see at the 4 there's an open circle. What that means is I do not want to include 4. So I write that like this. I say 1 is greater than or is less than or equal to x, and x is less than 4. So x is greater than or equal to 1. So it could be 1 or anything greater, and it's less than 4, which means don't include 4. Now let's fix the inequality below to correctly show the domain of the function. So the domain of this function is going to be from this dot to that dot. Because this is a filled in dot, I want to include that number. Because this is an open dot, I don't want to include that number. So this end, this goes to, let's see, so that's -4, so that'd be -1, -2, -3, -4. So this is between -1 and -2, so about -1.5. -1.5 is less than or equal to. Less than or equal to. So there's that. Less than or equal to x, which is less than 1. Less than 1. So again, I use that less than or equal to when there's a filled in dot, and I use just the less than when there's an open dot. Which best represents the domain shown to the left? So, they're all the same? No, they're not. No, they're not. I thought they were all the same thing at first. So, again, So I want to go from negative 1.5, and I want to include negative 1.5 and go all the way to 1. And I don't want to include 1. So negative 1.5, that is all the same. 1 is all the same. But again, I want to have a less than or equal to symbol over here. And I want to have just a less than symbol over here. So those two won't work. But this one and this one, they both have less than or equal to, which is good. And then the second piece, I want to have just less than. So not this one, but this one. So the x values of the function are greater than or equal to negative 1.5, and they are less than 1. Sure. All right. Now let's look at this domain of this function. So again, these are all the possible x values of this function, of this graph. So I need to use the less than or equal to, less than, greater than or equal to, and greater than. Since this side has a filled in dot, I know I want to include that value. So that's at negative 5. So negative 5 is going to be one end. So negative 5 is less than or equal to x. And x is also less than or equal to 8, 9, 10. And it does not include 10 because it's an open circle, so it's just less than 10. What is the domain of this function? So I have two filled in dots on either end. So I know I want to include this 8 and I want to include this negative 6. So the possible values of this function are going to be from negative 6, less than or equal to x, less than or equal to 8. Piecewise function will have more than one piece for its domain. Drag the points on the x-axis to adjust the domain. So again, the domain is our possible x values. It's where these graphs kind of show up on our coordinate plane. So the first one, so first one starts there and ends here. I think I'm supposed to use this over here because it has a dotted line. I don't know where this one ends. That makes it so much better. Okay, so I'll just leave that there. And then this one, these are solid lines. So those are going to go here. And then this one has a solid line on one end and a dotted line on the other. So the dotted lines correspond with these open circles, and the solid lines correspond with the filled in circles. Next page. Use a new line. So write the domain of the function using inequalities in the rows below. Use a new line for each region. So the first one I'm going to look at is this. And that looks like it goes from negative 6 to negative 3. Again, we're only looking at the x values. Only looking at the x values when we're talking about domain. So negative 6 is less than or equal to, since it's a filled in dot, and less than or equal to negative 3. Yep, and that's how that shows up. Now this piece goes from negative 2 to negative 1, but we're not including negative 2 and negative 1. It's just every number in between. So -2 less than x less than -1. All right, and now this one goes from 1 to 3. I'm not going to include 1, but I will include 3. So it goes from 1 less than x less than or equal to 3. And that's it for that one. We'll go on. Aha, now we're going to talk about range. So range is the set of y values we get after we substitute all the possible x values. So notice that the range of this function is y is less than or equal to 1, not just y equals 1. Why? Because there is a value where y is equal to 1. When x equals 2, y equals 1. So even though there's not a closed dot placed there, every point along the curve is a closed dot unless you see an open dot. So assume it's a closed dot unless you see an open dot. So let's drag the blue points to identify the range of this function. So range now is possible y values. Possible y values. Again, the dotted line corresponds with our open circle. Solid line corresponds with the closed circle. Right. Let's fix the inequality below to correctly show the range. So the range is going to be from up here to down here. I'm going to include this lowest value and this highest value. This is 2 and this is -2. So I'm going to go from -2. Instead of just less than, I'm going to have less than or equal to +2. However, why can't I don't know where my other terms went to. Aha. So if you do less than and then you hit the equal sign, it'll just change it to less than or equal to. Cool? All right, now let's look at this range. So again, we're going to look at this piecewise function. Piecewise function. And I'm going to identify the range of each piece, of each portion. So this first one is going to go from -6, or not, I'm looking at the domain still. We want to look at the range, the y values, up and down. So this goes from 2 all the way down to -2, 2 to -2. And I'm going to include both the 2 and the -2. So I get -2 less than or equal to, and this time instead of x, it's y. We're looking at y. And that's less than or equal to 2. And now, oh, yeah. Okay, and now this one. So I go here, I go from 6 to 5, and I don't include 6 or 5. So it's just 6 or 5, y less than 6. And now this last piece goes from 0 to 1.5. And I don't include 0, but I do include 1.5. Zeke claims that the function to the left should have 3 shaded regions for its range because it is a 3-piecewise function. Is Zeke correct? Well, that's what I did. I had 3 pieces. However, I don't know, it's a little confusing because this piece here kind of encompasses all of that. So if I'm looking at each piece, if I combine them all together and think about it as a whole, then I wouldn't really need to include that green piece. So I don't know. I'm going to guess that I'm not correct. Explain my thinking. Well, the range of the first piece includes the range of the third piece. So maybe I don't need to include that third piece. I'm gonna guess no, I'm not totally sure. Let's see what they have to say. Ah, that's it. Let's see if there's a teacher move. Though 3 separate shadings are needed to represent the domain of this function, only 2 separate shadings are needed to represent the range. Discuss, which includes writing a separate inequality, right? So we don't need to write that third inequality. We just need to include this one and this one. Why? Because this piece, this range, encompasses, it includes this whole, that range. Cool? So that's the last one. Again, these were all just an intro to kind of more of what we're going to be talking about in chapter 4. I want you guys to get these completed. You can watch these videos to help you get past any parts that were confusing for you. But don't worry too much if you're still a little unsure of these topics. We're going to go over them more after Thanksgiving, right? Hope y'all are having a great day. And if I don't speak to you, happy Thanksgiving. Enjoy your break.